Hello everybody, welcome to the Institute. In this particular case, I decided that instead of just giving you the answers to the electric circuits review here, I thought I would actually go through them. That way you can kind of think about what's going on. So our test is going to start with 6 multiple choice questions. One of the things that it'll deal with is capacitors. So I grabbed some capacitor questions. So let's start with number 1. We've got 3 capacitors. They're connected in series. The equivalent capacitance is 3 microfarads. 2 of the individuals are 18 and 9. What is the third? So remember, when you're in series, it's RAR. So it's reciprocal, add reciprocal. But I'm just going to stick with the raw part to start off with, that the reciprocal of my answer, my equivalent capacitance, 1 over 3, should equal the sum of the reciprocals of the other values, 1 over x. So I'm trying to solve for x. Easy way to do that is let's combine these two together, 1/18 and 1/9. That would be 1/18 plus a 2/18, so that would be 3/18, which is the same as 1/6. Plus I have a 1 over x equals 1 over 3. Just kind of drop that down. Now I need to get x all by itself, so I'm going to subtract this 1/6 to the other side. This is the same thing as 2/6, so when I subtract 1/6 from it, that's going to give me 1/6 equals 1 over x, therefore x equals 6. So I look at my answers and it looks like ding ding ding, D is my correct answer. Not a bad question, deals with this idea of combining capacitors together. Nice little multiple choice question. Number 2, we've got a circuit with 2 resistors and 2 capacitors. We're trying to find the time constant. So what we've got to figure out is what the total resistance is and what the total capacitance is, so that I can find the product of those two quantities. So 2 resistors in parallel is the RAR method. So I've got to take 1 over 12 plus 1 over 6. That's going to be the same as 2 over 12, so this would be 3 over 12, but then don't forget the end of RAR. We have to flip it over again, so this would be 12 over 3, or in other words, 4. So this whole thing acts like a 4 kilo ohm resistor. So 4, 1, 2, 3, 4,000 ohms. Over here, when you have 2 capacitors in parallel, you just simply add them. So 8 plus 6 happens to be 14, but that's 14 times 10 to the negative 6, because that's what micro stands for. So now I just pull out my handy dandy calculator, take my 4,000 times 14 times 10 to the minus 6, and I get 0.056. Looking at my answers, 0.056, ding, 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 looks like letter B. Great little question, getting to the time constant. Don't forget about how to find the time constant. Number 3, we've got 3 capacitors. They're identical, each having a capacitance of 2 microfarads. 2 of them are connected in series. Then the series is connected in parallel with a third. What is the equivalent capacitance? So if I have 2 of them in series with each other, and then they are connected in parallel with a third, my 2 and my 2, remember when you're in series you have to use the RAR method up here, so this is going to end up actually being 1/2 plus 1/2, which is 1, and then I do flip it technically, but 1 over 1 is the same as 1 over 1, and then I have a 2 down here, and then a 1 and a 2 in parallel with each other is going to just be 3, so it looks like D, this 3 microfarad. You're probably going to see more of like number 1 and number 3 pop up with my sample problem later, so I probably won't do this as much with the multiple choice, but I might pop into a multiple choice type of idea, but I tend to lean more towards putting those into the actual problem. The last one, number 4, you have 3 capacitors, 10, 20, and what was this other one? I can't see it because I covered it up partially. A 30. And determine the maximum equivalent capacitance you can obtain by connecting 2 of them in parallel and then connecting this parallel in series. So now I've got a situation like this. So I put these in here because they should have seemed familiar to what we've had. So whenever you have capacitors in series, they're going to be the RAR method. And one of the things that you find is the equivalent capacitance will always be smaller than the smallest capacitor. So if I want to make this as large as possible, I would want to make this as large as possible. So I'd make this the 30, and I would make these the 10 and the 20 over here. And so when I combine them together, 10 and 20 in parallel just get added. So this whole thing acts like a 30. And then I do the 1 over 30 plus the 1 over 30. But that's just going to be 2 over 30. Flip it over. So that's going to be 15 microfarads. So I come over here and I pick 15 microfarads. Now I always get a few people that look at this and go, can't I just pick the largest number? And notice that I have 60 up here, but I can't get up to 60. That would actually be all three of them in parallel with each other, and I can't do that with the suggestion that they actually gave. So this is the best I can do. Hope you enjoyed the beginning of the electric circuit review, and we'll continue after this.